行きます。朝まで行きます。
Even with this small application, we have sort of maintenance problems, and those maintenance problems will only get larger the longer it takes here. The problem here is basically we're creating our own HTML and we're doing it inside of the JavaScript code, and we're mixing two concerns. It's not entirely obvious at first that we're mixing two concerns, but we're sort of mixing together the program logic that is really important, and then the view logic, the things that get updated here. And when those two get mixed, it's much harder to evolve your application and to upgrade it later. It is kind of easy to go on and let's restart this one and to we can change the logic a little bit like this. Now we can just in the beginning instead, for example. Now that we have changed the logic, so let's try this. So some things that we had like this at the bottom. And now that works. We want this. Yeah, it works. Okay, fair enough. And then we can actually, inside of the startup block here, we can implement logic for the button. So we can give it an ID. Like the button. So when we, again, select on the back button, we put 2. And function do that. It's going to run this function. Right, so that works. And we can just run that. Run this. My students on the JavaScript course usually finish that one. Now I get it. Sorry. Anything what? How do you respond that? Something's still in the word. Brilliant. Yes, you're right. That's okay. Excellent, thank you. So one of us on the calibration, the other from the premises. Again, I could always program like this. So now we have to behavior for the automated reactor. And then we want the 0 here to be a bit special. So we give that a plan with an ID count, something like this. Right, and if we run this, you see 0 here, so the button still doesn't do the right thing. So it needs to go in and do the right thing here, namely, again, find the current count, which we find if we do select on count, and just pull out the HTML from the one. That will be a count. We can do count, plus field, and then put it back. So we say again, go to the count, sign here, and just change the HTML to the, well, I guess the string containing count. So this should update the number here. Yeah, so we have a like button. Again, this is probably the fundamental we did not today, and there are a lot of things that we ignore here. We ignore, for example, persistence or connection to the server. Usually this would be, a centralized number sitting on someone's server, and we just mirror it out. But the basic behavior is here, and we nowadays more or less expect the dynamic page to actually update this when we push the button, no matter what happens in the background. Now again, what's the problem with this dynamic code? We obviously do what we want. Well, the problem is not so apparent here. It works to program like this, and there are a lot of people have done a lot of code like this. But when you write a Docker application, you simply cannot stay in the DOM like this. Where is this number stored? Well, for a short while, when we're running this button, seeing here, it's stored in the variable count. But then this routine exits, and it's no longer stored there. It's only stored in one single place in this application, namely in the DOM. This is sort of the only 7 that survives between button presses. And that if it doesn't become maintainable after a while, we have a lot of things scattered across the DOM, and we cannot work like that, simply. So we need a model, and we need to make the separation between the model that sort of holds all the data, like this number 7, and the view that presents the data. And why is that separation so important? Well, it's important for evolving the application at all. Right, so 3 reasons to try and give them. 7 different frameworks. Angular is clearly out on top right now. They're doing 2 things right at the same time. That's sponsored by Google and they're open source. Well, all of those frameworks are open source, and that really helps, or is, let's say, necessary in sort of the open source landscape that is web development landscape. So it needs to be open source to succeed in the first place, but then it also needs sufficient backing from someone. It needs sufficient developers. It needs sort of good stable documentation. It needs someone to upgrade it from version to version. And making a project like this, and I'm going to help myself. I know that one of the hardest things to do is get volunteers for it to do all, the case jobs, the boring jobs. But with the Google backing, you basically have that. You can sort of throw money into maintaining the documentation. So by involving Google, we ensure that Angular has a future in the first place. And if you look at Google Trends, I'm pretty sure they haven't rigged this, and you search for different frameworks like this, compare Angular to the others, and you see Angular sort of taking off into the skies, and the others are sort of off to a good start, but not at all as impressive. On the other hand, if you do Google Trends with Angular compared to jQuery, I'm not going to show this, but you can try it at home later. Well, jQuery is sort of already miles above Angular. There's simply no comparison. Not that we think to be because we are sort of earlier in the trend with Angular, but it's also because jQuery is so remarkably established. People already know that they should be using jQuery. They haven't decided yet with Angular. But yeah, among the 7 frameworks, or 7-ish, Angular is currently leading this popularity contest. And then we have this very important reason it comes in at the second place here. And we can talk a lot about declarative views and so on. I'm going to show a bunch of examples with freedom from the DOM. Everyone agrees at this point that we need some kind of, well, not necessarily model view controller, but model view something. People sort of disagree about the third part here. And we just can't agree how to do this. And Angular comes out being both helpful at the same time as not sort of getting too much in your way for what you want to do. The most important part it does is it allows you to write your models. What do we mean by that? Well, basically you can write a small JavaScript application that works standalone without any involvement of HTML or the DOM or anything. You don't have to do any bindings at this point. You just write simple, easy JavaScript objects. So for a like button, for example, we would like an object with an increase method or a like method, something that increases this counter inside of it. And that's it. We can write those without even the browser, actually. We can write them offline. And they will say, well, then you plug them into Angular. And the fact that Angular allows you to do this, so write things separately like that, that's a great strength. And it doesn't have the separation as well. It's very alone in this actually. As you will see in some of the examples here, it allows you to do DOM manipulation in directives themselves. So the code for sort of being all messy with the DOM and so on is enclosed in these directives, and then you only use the directive in your HTML. So your HTML comes out as being very pure as well. Compare that to the jQuery that we have. Here we have all the manipulation, so again it mixes the application code and the DOM code. So let's look at an example of this. Let's look at ng-repeat. Right, here's documentation for ng-repeat, and here as well I need to switch on. And a bit paranoid with JavaScript for switching on in browsers. We have ng-repeat, and we also have ng-click, which is a bit like the back button. So what does the button implementation look like in Angular? Well, we have an ng-click directive here, which allows us to sort of go in and manipulate the model in any way we want. And for example, here we have it. It's basically a like button, and it works. And here's the source code behind that. So we can declare the entire page as an ng application. We can do that for the sort of the top HTML down here, or we can do it for the down only part of the page as ng. So let's add one and only one of these on the page. And this is really specific to Angular. And then we have the logic itself, and no JavaScript inside it. We just do ng-click equals counted from the DOM. So where did all the DOM manipulation go? Where did all the sort of funky fetching from the count here, and then incrementing and then putting back again go? Well, we only have incrementing left here, and that's what we are left with when you start talking just in terms of the model. We also have to actually initialize the model. So the way this works is that somewhere in memory, and we don't have to care about it too much, we've initialized a variable or actually a property here called sooner or later you're going to need a list of things, and the list will be dynamic, right? It's just like the other example we had here, adding things to lists. And here we have a smallish example. Again, we do the initialization here to have some list from the beginning. And then we simply have, you see this is a normal UL list here. And the repeat sits on the li, which means that in our HTML code we only declare one li. And then we say just repeat this one for a particular list. And then the important part here is that this works essentially like a for loop here. We say for this friends variable here, we declare a variable friends that iterates for it. And we also iterate, we'll see that in the example, but that's relevant. And then we can simply refer to friend inside here. It starts working like a template here, so we just go into different properties and talk about friend this, friend that, and it simply takes into the status structure, sort of only go creating as many list items as needed. Let's see this in action, and let's also see the filter. So this status structure here. Well, in a way, way, yes. The really nice win that we've eliminated is these things here, having to sort of worry about details of the DOM. So there are basically two data structures that are involved. There's the structure of the data itself, which is really simple in this case because we're just holding sort of one scale of value. But then there's the structure of the DOM also. And imagine you go ahead and evolve this application, and a lot of things happen to it, and other developers grab a hold of it as well. Sooner or later, the structure of the DOM will evolve. And when it does, you're basically screwed because you don't know exactly what parts of your application rely on that part of the structure of the DOM being in a certain way. So you get a lot of hidden dependencies between your application and the DOM structure. That's basically what you get rid of in Angular, because you all the time you declare your DOM structure up front, you put these entity repeats inside of the code, and you can sort of really move around these and without sort of touching the underlying model. And the underlying model here is completely separated. And if you change that one, well, you do have to go in and change all your entity repeats, but at least it's sort of very well separated, and you can see where you access things. And what's that answer to your question? Okay. And then finally, and this is perhaps one of the more exciting things and one of the things that sets AngularJS apart from the rest of the bunch, Angular is basically aiming to look towards the same place as HTML5 is aiming. So we have all these cool, nice technologies on the horizon, and AngularJS is taking them into account. Now, of course, there are no guarantees here because these things haven't happened yet, but as far as we can see, AngularJS is a good future investment because these things will happen in HTML5 anyway, and I'll talk a bit about those things. A very strange evolution has followed HTML in recent years. Basically, the people in charge of doing the specifications and everything like that, they wanted to build a big, nice semantic web, so they believed heavily in XML and XHTML and so on. And those streams were basically more and more coming to a halt. I wouldn't say that they're completely gone, but the semantic web has sort of had to leave the center stage for other things. What happens instead is that a bunch of companies said, oh, screw this, we don't want to be part of sort of this evolutionary part. We want to build applications in HTML. We want to build things like Gmail and Google Docs and Twitter and Facebook. How do we do that easily? And the answer for that from the specification guys from the W3C was basically, no, it's not an application language, it's a document language. It's supposed to build documents in HTML. All these fancy dynamic things with things feeling like desktop applications. And the people actually in charge of writing such applications, they said, screw this, we'll just make our own standards. And they formed a group called WatchWG, so in charge of evolving HTML into an application language. And that's what essentially became HTML5 later. And we're now calling HTML5. Now HTML5 has an enormously ambitious timeline. People sometimes mention the date 2020 or something like that. Well, some parts of HTML5 you can use already today. And my favorite page for showcasing that is htmlplease.com. I really like this presentation ability, but I also use it for sort of making informed decisions by creating web applications. Apparently we're supposed to avoid box protection right now, and if we want to read more about that, there's more details here, often there's links as well. And then sometimes we can use things, but we can use them with Quotient or with a sort of JavaScript library to fill in the missing details and so on. It's impressive, by the way, how often you can compensate for missing parts of HTML or missing parts of CSS just with some JavaScript. Basically, that is the saving grace that allows us to pretend that things like Internet Explorer 6 are not there. Or 8 these days, yeah. Internet Explorer 8 is the new Internet Explorer 6. By the way, just as a side note, did you see the campaign that Microsoft has against Internet Explorer 6? IE 6 countdown. We're almost done with Internet Explorer 6, by the way. Let's see. I think it's this one. Yeah, so which 10 years ago a browser was born, and now we want to kill it. It's showing a world map of how far along are we getting rid of Internet Explorer 6. The green countries here are the good ones. They're using very little of it. China is the big sort of bandit here in this game. I think because of old installs of Microsoft Windows and things like that, people simply cannot upgrade. But we're down to, well, this one says 100%, that sounds very good. But this one is still somewhere between 20 and 30% of this horrible. When I last visited this page, it says, I think, 95% or something like that. So according to this one, we basically reached our goal now. And yeah, the people are right. People are definitely talking about IE6 more than about IE8. Anyway, back to HTML5. So a really long timeline. People are bringing more and more of dynamic behavior and things you need for an application into HTML5. And things that have been sorely missing. And they're doing this sort of without breaking the web. Very important. So take the existing HTML and build those compatible features that allow us to do all the things we need. It's everything from smart form elements that understand email addresses and numbers and URLs and so on, finally, to things like real modules in JavaScript 6. So instead of doing this wonderful anonymous function hack where you put things inside of a pristine workspace where things don't set from each other, so you actually will have a module keyword. And that's one of the things that Angular will simply benefit from. Then we also have something called web components, which is meant to solve a number of problems at the same time. For example, it's supposed to introduce templates. You take a web component and you just fill in the holes that are missing there. That's basically what Angular is doing already. If web components get deployed, then Angular can simply use that technology, and because it will be built into the browser, Angular will simply be faster. So one of these days, sort of, some random day in 2015 when you've been using Angular productively for 1 year and a half, web components will land in people's browser, and things will just get a nice boost and nice speed. There's also other things like decorators, or allowing people to declare their custom elements, which is also basically what Angular already is doing. When you have these directives, you're basically saying, okay, this is an element that I want to behave in a custom way, and that will also become native inside HTML here. Which allows things to be inside the DOM tree, and still handle it as one single element. And that will also lead to a number of improvements. And we'll have imports between different documents. So that's Angular JS as well. The main thing here basically is that they are taking all these technologies into account, and they're basically building Angular in the same way to be supportive towards that. If you're interested in more details about that, you can see a presentation called let's see, Future of Angular JS. That's not right. Yeah, here it is.
English.
By the way, even though it's not here, it's rather clever marketing decision. Did you see the log type for HTML5? 5. Hey, so they're even in the same division like that. This is not my presentation, but it basically conveys the message that Angular loves standards as it is. And no other framework is doing this in the same way, so it's trying to align itself to these standards. And you can see here Today we're relying on a number of hacks for supporting modules. For example, we have offline things like Reply.js and AMD to actually make JavaScript programs or components able to call into each other. We have actually companies on this like OpenJS and so on, where Node is the big champion. We also have cool technologies like browser, which allows us to write things offline, maybe for instance, taking voice text across essentially code. But with technology modules, we can introduce it natively instead without having all these hacks. So the future of JavaScript is actually to make this fixed module something, and then we choose those things to export from these modules and what things to keep private. So no more hacky flags like this where we sort of invent the syntax that Angular has to support. What else? Then there's HTTP2 on the horizon. Today we have to do sort of request response for all these individual components of our application. HTTP2 promises that it's going to be a bit more clever than HTTP2 enabled server simply supposed to figure out, okay, this index HTML has all these sensitive dependencies, so just send them over the wire without a lot of requests. It'll be some time before that lands. The nice thing is that for once people don't have to upgrade their browsers, it's just up to the server providers to upgrade their HTTP2 here. So eventually we'll end up with sort of just boilerplate JavaScript with this better interoperability, and the tools are able to be do better introspection as well, because it doesn't have to sort of slam over all these boilerplate hacks in order to find the real code. And then we have web components with all of these things. Let's see, we have an example here. At this point we're writing a template like this with all these mustache-like curly braces, right? But the template is simply supposed to be a template element in HTML. So at this point we have to put them kind of not very nice into a script tag like this, and that declares, for example, the text Angular template, but that's supposed to be simply built into HTML. And well, it isn't parsed in the beginning, it won't pre-fetch your images, but it will actually wait. And there's a sort of security hassle because it's simply inert HTML as long as you don't use it. And we don't have to mess around with a lot of strings, which is always a bad idea, basically. Let's see. So here's the shadow DOM, for example. In this case, we're declaring a container like this. Inside of that, we have another template like this. So in the case of shadow DOMs, the other bits are hidden here because they don't matter to the outside world, and we just declare the component that matters. Right. So a lot of things, a lot of standards that are coming along with HTML will simply better support the things we are trying to do in Angular already. So here we actually might see one of these components where a library or a framework that we've started to use gets easier over time as it adapts to the new HTML5 technologies. There we go. That's the 3 reasons. Hello, my name is Chris Travers, and I'll let you guys on what happens when you put 500 million rows into a table usually heavily off the head of an index, how you solve the problems that come from that, and some of the other problems that can arise when you solve those. The second major difficulty we'll be talking about is what happens when you access data in a table that's perhaps 5 or 6 terabytes in size. Sometimes breaking first normal form is necessary to keeping the performance up. But as you're probably aware, breaking first normal form is not free of charge. There are problems that come from that. We'll be talking about what sorts of problems arise in terms of the perhaps getting data back from a select query that doesn't make sense. And we'll talk about how to avoid those. Finally, we'll be talking about how you can use some of the advanced features of PostgreSQL to provide access to data in a semi-structured environment that you would probably think a relational database is not very good at generating for you on the fly. We'll talk about how we use PL Perl, but PL Python or PL V8 for JavaScript to use this stuff. We'll talk about how we use this functionality to provide access to the inside of structured text documents. So if any of this interests you, I'd recommend you come by, register on our site. The talk is on February 9th in the evening at our office here. Hope to see you there. Bye. Okay, let's dig into this topic. So when I was thinking about how to talk about reactive programming, I sort of reached around for some analogy, something in my past or something that I could relate to easily, and I found one thing that was very easy for me as an Englishman to talk about, which is the extremely sophisticated matter of drinking beer. Yeah. So drinking beer. It's depending how you factor it, kind of imperative, right? I mean, this is an imperative implementation, or at least a flowchart of it for drinking beer. Why is it imperative? Because it's got a loop. The loop is, it's an imperative programming construct, right? It's one of the things that we use day in and day out. I'm sure like writing functional code all the time, we use those. But this is basically the way that we would look at it. We sort of say, while true, because we don't want to stop, order, and then drink, okay? And so we go. But actually, this is the way we must have had to write it in, say, C# back in the days of version 1, version 2, the bad old days. But over time, things have changed, and we've got more options. We can express it in a much more functional style here. I like my beer to be very pure, so this is a very pure way to drink beer using functional programming. So what's going on here? Well, the first thing that I've done is grab these things. There's a library called the interactive extensions, which basically gives you a bunch of extra things on enumerables. I don't know how many of you here read C# easily, or does anybody else read C# easily here? Nobody? We got one, okay. Let me tell you what this is doing anyway. So what this is doing is it's basically getting the menu here, which is an object representing the menu appears. And what I'm doing is actually making an infinitely long sequence of menus here. Okay, so I'm getting the menu and then I've got as many as I want. Now of course it doesn't compute that because your computer doesn't have infinite memory. What it does is it sort of hands you the menu, so you need it. Just like when you go to drink at the bar, you can actually the menu as many times as you want. And then what we do is we take the menu and we choose a beer, and that's chosen one, and then we order it. Okay, and then we take 4 of them, that'll do. That's a fairly light evening drink, but that's okay. And then we'll do it off for each, and we'll just pass this drink method off to for each. And if you kind of look at this, interestingly, we don't actually do any work until that very last statement there. In fact, the way that this works is that all of this in green is what's called lazy, kind of like the other one. Okay, so what it does is it just sets up a little pipeline here. So it says, okay, here's a menu, and here's something that can produce lots of menus, and here is something that produces a choice, and here is something that orders it, and here's something that basically keeps putting values through this pipeline until we've seen 4 of them. And it's not a that we actually get down to the very bottom here. That we actually need values. For each is something that demands values. This is like a heap something to work on. So the thing about all of this is that it's blocking. Okay, so that call there, that order. Okay, what happens when you're breaking beer and you have to order more? You block. Okay, you're sat there waiting. Feels like an eternity. Eventually it comes. Okay, and then you go and look, you're blocked here. And blocking is something that we, happens all the time in our programming. I really like to just label this as interactive beer drinking, which is often sort of seen as the opposite of reactive, which is what we're here to talk about. It is actually pretty awful, I think. But the thing is that we are so used to it that it gets us in harder times that sort of captures the problem in a different way. Really, blocking is part of the whole paradigm of interactive programming, where we make synchronous calls, okay, so I call a method, and what I expect is that the method will completely produce a result, give me a result back, and there we go now. And beer drinking is typically interactive. And at this point you might sort of wonder, why did I pick it if it's a bad example of reactive? And the answer is, when I lived in Slovakia, I discovered that reactive beer drinking exists. Okay, so how did this work? I cannot believe this is my first story. Okay, at the end of the table was a bottle of beer. And every so often, beer would be pushed to the table, asynchronously. Okay, so waiters would come, or waiters would come, just more beer on the table. And then the drinkers would, observe this drink slipper, and as soon as they needed another one, they could just take it. Okay, this is very nicely loosely coupled beer drinking here. But this is reactive. This is, just reacting to the fact that someone has actually put a beer in this place that you're observing. And of course, you can have a whole little workaround from that. So, this is asynchronous and non-blocking beer consumption. And, well, sounds good. But, the thing is, when we hear things like asynchronous, one of the common reactions, maybe feel this is, oh, that's the hard kind of programming. If we think asynchronous is a bit harder than synchronous. Yeah, that's me too, okay? It's human. If you look at the way that people work, we like to tell stories, we like to talk about what we did in the day, and it's all very synchronous. I did this, then I did that. We don't tend to talk about things happening in parallel. It's not so much in our nature. And we kind of challenge on that when it comes to asynchronous programming, because things can be happening at the same time in any order, and I think that's why we find it tricky. And of course, even just looking at this simple situation of somebody bringing beer to a table and people asynchronously taking it, okay, what happens if, as, the Slovak waitress is putting the beer there, and I sort of reach out my hand, and I meant to take a beer, but I'm holding hands with her. Okay, I'm resistant to Slovak with a condition. So, thank you. So, okay. So the other thing is all the callbacks that tend to characterize a lot of asynchronous programming as well. The idea that, well, okay, we've set this operation off, and when it's done, here's a piece of code to run. So what happens if you want to do something when that has also been done? Well, we could nest another piece of code in there, which makes another callback, and you end up like 20 levels in addition deep, and it's really horrible. So in general, asynchronous programming has sort of been one of those things that traditionally we maybe have tried away from, because it is different. The tools have often actually not made it easy to practice things well, and that is, I can take two things and put them together, and they still ostensibly easy to do that. So let's take a look at what the reactive paradigm sort of sets out to do, and how it tries to take on this problem, and why it takes it on in a way that we should be able to find reasonably graspable. Now, if you think about interactive programming, or doing anything like this, what we're doing is essentially pulling. Okay? So I mentioned to you that whole top bit is lazy. What I mean by that is that down here, when we want to have a drink, we call up to something here, and in any language with some kind of iterator, or a numerator, or whatever names we like to give to these things, there's always a method like move next. Okay? Give me the next thing. So all these are method calls. They're called all the way up the chain. Okay? So give me a value. No, I can't. But this I can. No, I can't. Maybe he can. Maybe he can. Okay. Finally a value. Okay? And then the results flow back down the pipeline until we do something with it, and we can pull more of them through. So this is very pull-based. And it's all about enumerables. What's going on with that code that I showed you, that query, that is selecting this and just dragging it through a pipeline there, is it's setting up a chain of enumerables, okay, or a chain of enumerators, things that know how to produce a sequence of values, or take a list of values, manipulate them, and give the other one back. Now, the enumerator pattern is something that's been very long known, and we can define lots of what we call combinators on this. Now, a combinator is just one of those fancy words for a thing that only operates on the parameters we give it, okay? So if you think about select is a prediction. It's a thing that takes, okay, here it takes in the chosen beer, and it actually gives out the ordered beer, okay? So it takes in an enumerable. And each time it has to go value, it says, okay, so the current one that I just bought match. If yes, hand it off with done. If not, no, ask for another one until one does match. So what we're doing is just wiring together these little pieces that know how to obtain a value from somewhere. Maybe manipulate it, maybe transform it, maybe make groups of them, maybe select or filter them, and so on, and then pass on results. The reactive paradigm basically arose out of realizing that there's another design pattern, besides the enumerator pattern, which has a very interesting relationship with enumerators, and it's the observer pattern. Does anyone use observers? Yeah, what do you use observers for? Anyone? Yeah, reacting to change. And the observer pattern. What's the observer pattern? I'll come back to that. It's really great. Okay, let's do this one. The observer pattern is where we're observers. Okay, we have an observable object here. And the observers subscribe. They say, I'm interested in knowing stuff about you. And whenever something interesting happens over in this object, it's got this list of observers and it goes and notifies them. Okay, it tells them, oh, something happened. Or something happened. Now, why this relates to category theory, there's a concept called mathematical duals. Basically, duals come out of category theory. Now, I'm not a category theorist, but essentially there's one really, really important result that comes out of all of this. All of those combinators, like where and select and let and so forth, that make sense to define on enumerables, also have a sensible definition on observables. Okay, so you can actually, and you can sort of see this, let's take where, okay, you can have a value asynchronously being pushed at you. too, right? Yeah. Okay, fine. One day I'll have a room of people who will find this funny, and then I'll run away. Okay. So, alright. The reactive extensions. So, well, this actually came out of Microsoft Larry Fine, very, very cool guy. And he was heavily involved in bringing this Link, which is the very nice language integrated query stuff that I showed you before. But it's actually pretty sneaky because Link basically is a bit of functional programming, sort of sneaks into C#. And I'm like, oh, that's great. I'm realizing they're doing empty. I kind of like it when you design something that lets people use fairly interesting and great concepts without sort of running into the, oh, you're doing this cool thing, this concept. Not people to deal and solve their problems. I kind of like languages when you do that approach to language design. But anyway, we got Link, we got the ability to write these queries over these sequences. But the thing that they did is they basically made it independent of the source of data you had. So if you wrote a Link query, and your data source of the database, there's enough information around the runtime to translate that into SQL and send it off to the database. And there was enough flexibility that, for example, queries over objects they could just take and then drop in a new implementation called ParallelLink.
これ昔の使いられるんじゃないですか?
Very elegant design. Now what they realized with RX is that the same sort of infrastructure can be used to set up chains of observers. So it actually implements a lot of the same combinators, select, where, so forth, people used to, maybe, from doing things with, say, Link, or the languages that provide any kind of functional programming support. Maybe they call them map, filter, or map and grep. Okay, there's lots of names for these. But, you know, they all have them. And the UCRX was realizing, oh, well, we can do these on observables too. So I'm going to show you some examples in C# today, and just to show you how you can go and play with this, by the way, if you want to, you just go and install RX from NuGet, okay, and then let's try and have a little bit of RX here. So we'll just finish up the VR example first. It's kind of silly, but it makes sense to finish on this path now where we started, and then we'll do some really cool stuff as well. Okay, so let's get just a random number generator here. Okay, what we're going to do is we're going to take the class observable. Now, observable has a bunch of methods on it that manipulate observables or produce observables. Remember, an observable is something that we can choose to observe. And this first thing here, called interval method, okay, here in a time span of 2 seconds, what this does is it creates an observable. And if we start observing it, what will happen is every 2 seconds it will just send us an integer. Okay, it'll send us a 0, 2 seconds, 1, 2. Okay, you get the picture. So what's going on here is every 2 seconds we're notifying anyone who's interested. So it turns out that this selected, okay, because being just changed as a bunch of method calls means I'm interested in observing the last thing. So it sets up all of this observing for you. So this select here, every 2 seconds we'll get a number which it completely ignores. Okay, because we're not really interested in the number which is interested in defining here. And what we'll do is we'll choose a beer. Okay, so here is the menu, and I'll just pick a random one. Okay, that's just between 0 and less than the count there. So we'll pick a drink. Okay, and but of course we're already picking here because we thought, but this is the waiter's view of it. Okay, every so often, more than 2 seconds, but every so often the waiter is going and they'll say, oh, I'll pick this one. What they do is they go off to the table and they're going to serve a round of this. Now, do is something that essentially lets us just sort of a little side effect in there. It's something that lets us just say at this point in the pipeline, I'd like to just run a piece of code. And sometimes this is kind of useful because what you'd like to do is, you know, is actually take what you've got so far and just write it out, even the debugging, or maybe you want to log something or something like that. So what I'm doing there, I'm going to say serve the round of that. Okay. Now we've been instructed that we should only serve the round of the okay. So and then what we're going to do is we're going to actually make this into something that many people can observe. Now, one of the things I have ways about that is kind of important to understand is the point that this whole pipeline of observables actually starts coming into play. Now, the thing is this. When I set up this pipeline on the take 4, I've actually only described it. Okay? This is called declarative or just declaration. I haven't actually started producing the 2 second signing yet. Okay? I haven't done any of the work before the nothing yet. What we've done is it just says something else, so if somebody comes along and subscribes, okay, it's the whole subscribe method. At that point, what will happen is we'll go all the way up the chain until something is at the start of it, we'll subscribe, we'll start observing all the way up, okay? And eventually from here we'll go down to 2 second pulses. The thing is that we actually can have all the you want to tell different places that something happens. What you do is you sort of have events and you publish them, and then your application listen to them and then you write them. Okay, what we're going to do is we're actually going to do this subscribe with this. So what we're going to say is at this point, if anyone actually comes and starts observing this table, I don't want you to go all the way up this pipeline and start another round of drinks. Okay, I want to share this between the whole table. And the table connect method is there just to say, okay, we're ready to start now. That actually makes this go and do the subscription up here. Okay, so here are some drinkers, okay, slightly fabricated. You can see I'm kind of fast, and my box is slowest, so tell it, it's not here, it's fine, for the video. Oh well. Okay, so here is what we do. We have this iObservable. So this might remind you of IEnumerable, okay? The interface describing an enumerable, something you can pull. And just like IEnumerable is type parameterized, so, you know, is it a bunch of strings we're getting, is it a bunch of cats or whatever, IObservable also is. This sort of tells you what sort of values are being pushed, okay, for this pipeline. So what I can then do is I can take that table, I can say I want to actually observe it over on the task pool, okay, so we don't block. You'll notice that I'm doing this over here in red, okay, and what I'm going to do is I'm just going to do a side effect there and it's going to wait until we've seen all of the things. You might remember the take 4, which means only 4 things are going to go through, okay, and we'll wait until they're done. So what will happen with this is that all of the drinkers, okay, will be looking at the table, and they'll be attached to the same flow around the drinks, and they can all take one, and then consume it at their own pace. And of course, if I run this, let's try this. Okay, was that the one? That was not the one. That's the one. Okay, and if I run this code, then we should start seeing rounds of drinks. Okay, you can see that they're coming out at different paces because people are going at different speeds. Okay. Cheers. So, there we go. Okay, so you can see that there actually is a little bit of getting this in and do something. You might do it quite a lot when you're debugging. You probably will do this less in real life, okay, just as a problem. So we might not see too much of this again for the rest of the day. And the reason is that you often don't quite want to do it that way. Okay, it's good for demos. And then this one also. Okay, because what you're doing here is a little bit funny. What we've done is we've actually taken this sort of thing that is throwing values at us asynchronously, and then said, oh, synchronously, wait for it. Okay, so there's a bunch of places. It is kind of everywhere. Ever since web services have come along, when you go and you make this call onto this web service, you don't know when that's going to come back. And the service you're calling, your service doesn't know when it's going to arrive. It's a part of the domain application. All of the inherent concurrency in that. Things can be happening at whatever different times they like. User interfaces. Okay, that's lets you. The user can click the button whenever they like. They can type in the text boxes whenever they like. And why things get interesting is when we take various of these domain events as well, like sockets, okay, we'll talk about a little later. But the thing about all of this is that it gets especially fun and hard when you have to start doing multiple of these together. So for example, I have a user interface with a search checkbox in it, and the user types something, and they go off and they start taking requests over a web service. Then the user changes what they type in the text box to correct spelling mistake. At that point, we go off and make another call to the web service. Now it turns out that second call, by some fluke, comes back faster, and we show the user the results. And then, straggling on behind this call from this other web service, the first call that we made with the input the user has now deleted and replaced, comes back as well. What do we do? Well, obviously the answer is we should ignore it, because we're already showing the correct information. So that's actually kind of tricky. That sort of problem is not that easy to solve. It's pretty easy to not think of it, and to end up getting it wrong. And I know, because I've seen plenty of code bases, and especially JavaScript, where it's very common to go off and call services, so make those kinds of mistakes. So it's not just an asynchronous all around us, it's that we're often expected to compose and put together different kinds of asynchronous things, either user interfaces or service calls, and that's driving over WebSockets, and maybe domain events, that is events from within an application that carry some kind of significant meaning in that domain. Some of this, you can clearly see is related to systems being more distributed. Synchronous programming and distributed systems are not a very good thing. You may have seen systems where you make a web service call, but in order to answer that service call, it has to make a service call too. Okay, and you end up with all of these calls. And you get a value from each one, and you run a piece of code which takes the two values and returns one value. Okay, and you combine them together. That's it. Okay, just this two sequences into one. Now, of course, doing that for the variable is easy because you just pull a value from one, pull a value from the other, pull a function and pass it along. This, when you're doing asynchronous reactive programming, is much trickier because what happens is, as a value arrives, okay, here, another one might arrive here. Before a value is pushed towards the second one, so it has to have some sort of window there of, buffer of incoming values. It has to deal with the fact that both might arrive at the same time, so it has to do the other length of make sure it's thread safe, because it could come from different threads. Okay, so RX is not just factoring out the observer pattern. Because of the asynchronous nature of things, it's factoring out doing all of that messy stuff, locks, or lock-free stuff, or all of that you probably don't want to have to deal with. Now, along with this, you may have come across something called the Reactive Manifesto. And this talks about reactive applications. And the idea of this was just taking this idea of reactive programming and saying, what if we apply it to the whole system? Basically, build systems of reactive events, flows, failure, and users. Okay, and you can actually think back to the thing I talked about a couple of minutes ago, about what happens if the user, types in something, changes it, and we get the wrong results. Okay, that's what users want. They want applications that react to their calls and do the right thing. Here's just a couple of quotes from the Reactive Manifesto. I won't read it, but you can see that it's kind of describing the sorts of changes in the kinds of systems that people have to build. Okay, talking about the architecture that is very asynchronous in nature.